Good morning, everyone. Good morning, everyone.
Good morning, ma'am.
Good morning, ma'am.
Okay, today I am going to start current electricity. You have already have an idea about current electricity, right? Because I have already told you in the practical class also some of the topics from current electricity, and in the electrostatic chapter also I have told you some basic ideas about this sector. So actually when charges move, it produces electric current. Okay, so we know that when charges at rest, it produces an electric field around itself, right? And when charges move, it produces electric current. So this is the definition of electric current. We will consider electric current by the symbol capital I, and if q amount of charges flowing in an electric circuit in time t, then the formula for electric current I equal to q divided by t. So basically electric current is the rate of flow of electric charge. You can write down electric current is rate of flow of electric charge. So this first I is the symbol for electric current, and Q for electric charge, and T for time. So Q divided by T equal to I. Rate of if Q amount of charge are flowing through a electric circuit in time T, then the amount of current produced in that circuit is I equal to Q by T. Please write down this line, because here it is not written that if q amount of charge flowing through a electric circuit in time t, then the amount of current produced in that electric charge is I equal to q by t. Amount of electric charge produced in that electric circuit I equal to q divided by t.
Ma'am, can you repeat?
Okay, if in an electric circuit q amount of charge, small q, q amount of charge is flowing through the circuit in time t, then the amount of current produced in that circuit I equal to q divided by t. Basically, you can also write down this line also. Basically, current is the rate of flow of electric charge. Current is the rate of flow of electric charge. Okay, so the SI unit of current is ampere. Name after the scientist Andre Marie Ampere. So SI unit of electric current is ampere. Okay, so we know that when Q amount of charge flow in a electric circuit in time t, then the amount of current produced in that circuit I equal to Q divided by T, or current is the rate of flow of electric charge. So we also know that the amount of the SI unit of electric current is ampere. So what is the 1 ampere current? If someone asks you the definition, what is the 1 ampere current, then 1 ampere current is constituted by flow of 1 coulomb charge in per 1 second, or per second, or in 1 second. If in an electric circuit 1 coulomb charge passes through the electric circuit in 1 second, then the current produced in the circuit will be 1 ampere. So this is the definition of 1 ampere current. So this is an important topic. The question will come from this topic, that what is the amount of 1 ampere current, then or the question come like this, the what is the definition of 1 ampere current, then it is, if in an electric circuit, if 1 coulomb charge is passing through the circuit in 1 second, then the amount of current produced in that circuit is 1 ampere, or 1 ampere equal to 1 coulomb divided by 1 second. Okay, 1 ampere equal to 1 coulomb divided by 1 second. Or the instrument emitter measures electric current in a circuit. So emitter, the instrument which can measure electric current is emitter. Next is Ohm's law of resistance. I think we have already discussed about Ohm's law in the practical class, that according to Ohm's law, current potential difference is directly proportional to electric current, right? A basic law regarding flow of current was discovered by J.S. Ohm in 1828, long before the physical mechanism responsible for flow of current was discovered. Imagine a conductor through which a current I is flowing. Let V be the potential difference between the ends of the conductor. Then Ohm's law states that V proportional to I. That means potential difference is directly proportional to the current. Potential difference or voltage. So if voltage is higher, the current produced will be more. If voltage is lower, the current produced will be less. So potential difference is directly proportional to current I. So we cannot get a particular value by putting the proportionality signs. So we need to remove that proportionality sign. To remove that proportionality sign, we need a constant. We put the constant as R. So V equal to IR or RI. So R, the proportionality constant, is called the resistance of the conductor or resistance of the circuit. The resistance will always try to oppose that current. Okay, resistance will always try to oppose that current. So according to what is the formula of Ohm's law? V equal to IR. According to Ohm's law, we get V equal to IR. And the definition of Ohm's law is, according to Ohm's law, the potential difference across the conductor is directly proportional to the current produced in the conductor. And V equal to IR, where R is the resistance of the circuit or resistance of the conductor. Okay, so for what is the SI unit of current? We have learned that the SI unit of current is ampere, and at an SI unit of potential difference is volt. Okay, you can write down SI unit of potential difference is volt. VOLT, volt. Okay, so SI unit of potential difference is volt and SI unit of current is ampere, and the SI unit of resistance is ohm. So ohm is denoted by this symbol. Okay. Okay, so SI unit of resistance is ohm, which is denoted by this symbol. So again, as the we have already know that the definition of 1 ampere current, right? Now you have to define the definition of 1 ohm resistance. Similarly, as the 1 ampere current, now we have to define that 1 ampere 1 ohm resistance current. You have to define 1 ohm resistance. So the potential, if the potential across the two ends of a conductor is 1 volt and the current flow is 1 ampere, the resistance R of the conductor is 1 ohm. Okay, so if 1 ampere, if in a electric circuit where potential difference is 1 volt, where potential difference is 1 volt and current produced in the circuit is 1 ampere, then the resistance of the circuit or conductor is 1 ohm. If in a circuit potential difference is 1 volt and current produced in the circuit is 1 ampere, then the resistance of the circuit is 1 ohm, or 1 ohm equal to 1 volt divided by 1 ampere. Here from this V equal to IR, so R equal to V by I, right? So 1 ohm equal to 1 volt divided by 1 ampere. So students, do you have any questions up to this? Any question or any doubt? Yes or no? Do you have any doubt or no? Or you have understood everything?
No doubt, ma'am.
Okay. Okay, so you have know the definition of 1 ampere current, you know the definition of 1 ohm resistance. Now tell me the definition of 1 volt potential difference. From these two equations you can define 1 volt potential difference now. So tell me the definition of from this equation. From this equation tell me the definition of 1 volt potential difference. 1 volt potential difference. Tell me the definition of it. As like 1 ohm resistance and 1 ohm resistance and 1 ampere current. As like these two definitions, tell me the definition of 1 volt potential difference.
Ma'am, let me just try, okay?
Okay.
Uh, if the conductor has 1 volt and the current is 1 ampere,
Mm-hmm.
then the conduct or then the resistance of the conductor is one ohm.
Yeah, resistance is 1 ohm. I am asking about the definition of 1 volt potential difference. Ohm already I have given na here. Ohm of 1 ohm
Yes, ma'am.
resistance. I am asking what will be the definition of 1 volt potential difference. Try, your first part was correct. You can try like this. See, if the if in a conductor current produced is 1 ampere and the resistance of the circuit is or resistance of the conductor is 1 ohm, then the potential difference across the conductor is 1 volt. Okay, you can write down, if in an electric circuit the current produced is 1 ampere and the resistance of the conductor is 1 ohm, then the potential difference across the conductor is 1 volt, or 1 volt equal to 1 ohm into 1 ampere. 1 volt equal to 1 ohm into 1 ampere. From this equation, 1 volt equal to 1 ohm into 1 ampere. Okay, all of you have written down the definition of 1 volt potential difference.
Yes, ma'am.
Okay. Okay, so resistance in a system of resistors. So we know that every material has its own resistance. If in we are making an electric circuit with some material, it can be copper or anything. Okay, so not anything, the conduct which are conductors of electricity. So if we are making an electric circuit with a material, the material have its own resistance, then the material will have own resistance and it will try to oppose that current, and we can apply resistance from outside also. Okay, if we are applying resistance from outside, then there can be two kinds of resistors. uh, See, resistance is the thing and resistors are the device which will produce resistance. So, if we are applying resistance from outside, there can be two types of resistors. When resistors are in series and when resistors are in parallel. So, this is a large topic. So, I'll discuss in the next class about briefly about resistors in parallel and resistors in series. So if you have any doubt in today's class, you can ask. And you can give your attendance now.
Ma'am, what is the function of resistant or resistor?
Resistance. It is the definition. If resistance is the thing which will try to oppose the current. Okay, So if in an electric circuit V is the potential difference and in that circuit current produced is I, then the resistance of the circuit will be R. R equal to V divided by I. This is the definition of resistance. R equal to V divided by R. Resistance is actually the constant which we'll call the constant of proportionality here. So R equal to V divided by I. I will send you this PDF in your WhatsApp group. You can write down the notes.
Okay, ma'am.
Okay, thank you everyone.